and Associates, which is and he's a consulting engineer in that firm and has been for about 20 years. He previously worked with Environment Canada, and it was a former director of Canada's National Hydrology Research Centre. His interests include interjurisdictional water management, floodplain management, and the effects of climate change on water resources. And so that's our introduction to Bob. Welcome, Bob, and I turn it over to you.
Thanks very much, and I appreciate the opportunity to meet with you tonight. And as my slide template shows, among other things, I'm also a member of the Saskatchewan Environmental Society, and this talk is based on some talks I've given for them as well, and that's why the logo is on here tonight. But at any rate, what I'd like to do is, almost as the title says, just talk a little bit about waterways of Saskatchewan, and with some emphasis on lakes, because I know that's your interest. And I'll just close, I think, in time to have some questions and comments as we proceed. But I'll just move ahead the slides and start the show. If I can, here we go. The first thing to mention is that Saskatchewan is a little bit unusual. The province actually contains 3 continental drainage basins. In this illustration, the area at the very top of the map, all that water flows north to the Arctic Ocean. At the very bottom of the map in the southwest, that water flows down to the Gulf of Mexico. And the water in the kind of in the middle, if you like, is Hudson Bay drainage, and it flows generally east towards Hudson Bay. And as one of the consequences, as someone said, Saskatchewan is hard to spell and easy to draw, but we have all of our major river systems cross boundaries, whether it's international boundaries, interprovincial boundaries, or boundaries with the Northwest Territories. And that's a very significant item in water management from a Saskatchewan perspective. The other thing I should mention in kicking off is that there are really 4 key ecozones in this province. And at the very top of the province, there's the Taiga Shield. And then coming down from Lake Athabasca in the kind of a northeastern third on an angle is the Boreal Shield, which, as you might have guessed, contains the Canadian Shield. So it's rock and trees. And then we get further down into that transition zone, which is known as the Boreal Plain. And that includes a lot of the land from sort of Yorkton up towards Meadow Lake in that area. And then finally, in the bottom part of the province is the true prairie. And it's important that we kind of understand each of those areas and how hydrological processes work out in those different areas. So that's my starting point. And in terms of the southern parts of the watershed, the southern parts of the province, the main things I'd like to emphasize is that, first of all, it's flat, and we know that, but it's as geographers and engineers say, it's a low relief, and it's just a series of small depressions and potholes and ridges. And the end result is that we have what we know as disorganized drainage. There's not a lot of major rivers and channels. And I should point out actually that the North and South Saskatchewan rivers, which flow across the province in the south, are really the only source in Saskatchewan of reliable and high quality drinking water for use in the southern part of the province. And in fact, 80% to 90% of the water we see in the North and South Saskatchewan River are actually mountain runoff. So very little runoff contributes to, from Saskatchewan contributes to those streams. So when I talk about disorganized drainage and that sort of thing, it's the prairie drainage that I'm thinking about. We do have the major rivers crossing the province. The other thing is that it's what climatologists call a humid continental climate, which basically means severe temperatures, and you know, it's not rainforest and it's not desert. But in the southwest part of the province, it is technically semi-arid land, and rainfall is minimal, and evaporation is considerable. And generally in that southern part of the province, evaporation does exceed precipitation almost inevitably. And the typical runoff pattern in this part of the world, in the south, and by south I mean Prince Albert and south, roughly speaking. But we have an April snow melt, and sometimes rain with that snow, and we get significant runoff in the spring. And then a lot of streams just dry up completely. There's very little groundwater fed base flow in the southern part of the province. And quite often, even if we have a heavy rain like we've experienced in the last few days, it doesn't lead to much runoff. It tends to just help water crops, and it certainly has a big role to play in agricultural productivity. Another key point about this southern part of the province is this, what we tend to call the question of non-contributing drainage. And this map shows in red what has been defined as non-contributing drainage. And by that we mean the land that would contribute to natural stream flow on average less than or about 1 year in 2. So it's, you know, those of you who have a mathematical background, it's the median flow that would cover this non-contributing drainage. And of course, this includes the North American duck factory, the pothole country, agricultural lands, however you wish to define it. And I think the important point to make when you see a map like this that speaks to non-contributing drainage is to point out that one of the consequences of land drainage is you start connecting up some of that non-contributing drainage. So this is land that's been defined as naturally not contributing to stream flow, except 1 year in 2. The other thing that we can talk about is the whole idea of watershed classification and trying to understand our different watersheds. And I'll explain more about that in the next slide, but we need to understand how these smaller watersheds behave and what affects them, what doesn't affect them, just how do they change with different conditions, and what happens if we push on a watershed, and by pushing on it, we put a lot of water on it, or we take a lot of water off, or we drain it or modify the land cover. All of those things lead to different outcomes, and we need to understand that better. And so if we look at the southern part of the province and consider things like climate, topography, the surface geology, wetlands, land cover, all of these kinds of characteristics of southern Saskatchewan, we can then create maps that show very distinct sub-watersheds. And we'll show this in the next slide, where this is an illustration of work done by Gerald Wolf and his colleagues at the University of Saskatchewan. And they've taken the prairie ecozone, which is that southern agricultural area of prairie Canada, and through a number of processes classified that landscape into different types of watershed classifications. And you can see that a large part of southern Saskatchewan is what they call pothole till, or that's really the pothole country that we get to appreciate in Saskatchewan. You can see in that area around Regina that's basically old lake beds from glacial lakes and from many, many eons ago. But the key point to make with this figure is that the University of Saskatchewan is presently working on looking at the runoff characteristics of each of these classifications. And in fact, you find that in some parts of this area, one classification of land behaves quite differently than another classification of land. And this becomes important when you're considering things like effects of land drainage, because in that pothole hill country, land drainage can lead to significant changes in runoff. In other parts of this prairie ecozone, you can modify the land drainage quite a bit and not lead to increased runoff. So it's important to understand, first of all, that land has been classified across the prairies, and that we're working very hard on trying to determine how different classifications respond to things like changes in climate, changes in drainage, heavy rains, light rains, all that sort of thing. And so this is work in progress, but I think it's quite exciting work, and it's certainly something that couldn't have been done, 30 years ago, before we had all these powerful tools to analyze landscapes and work with them. I'd like to turn now to climate, and there are many ways of considering climate on the prairies, and people that are concerned about drought years ago developed what's known as a Palmer Drought Index, and it basically takes precipitation and evapotranspiration and soil-related data and produces an index of dryness. And similarly, the second one on this list is another precipitation type of index based only on precipitation. But more recently, climatologists have developed something called the Standardized Precipitation Evapotranspiration Index. And it's quite a mouthful, but it considers both precipitation and potential evapotranspiration. So that's the evaporation from the landscape, but also transpiration by plants and so on. So it's a very well calculated index, and it's becoming more and more used. You'll see it in a lot of documents. And the reason I wanted to mention this is if you look at these SPEI indices for the last 100 years, and these two illustrations are both at Prince Albert and Regina, and there are a few things I can point out, and namely if you look at the 100-year record, first of all, you see that at the very beginning of the 1900s, when people were first settling Saskatchewan, it was an unusually benign climate. It was wetter than normal, and settlers swarmed in and started farming, and and then of course later on the weather reverted to normal, and that ultimately led to the dirty 30s. But I should mention on these charts the black dotted line is what's known as a 5-year moving mean. So you can see in that early part of the last century where the black line is above average, showing above average moisture. And then as you trace that line, you can definitely see the 1930s. You can see wet periods in the 1950s, wet periods in the 1970s, a little bit of moisture in the early 90s. And then, but the key point I wanted to mention was once you get to about 2005, you can see it's been consistently, almost consistently wet. Maybe Regina has a few dry years, but for the most part, this last period from about 2005 up to about 2015 has been very, very wet. And so when we start trying to examine the results of rural flooding, high lake levels, all of those issues, we have to consider not only what people have done to the landscape, but we also have to consider a climate that we're experiencing. And as you all know, since about 2015, things have dried up a little. So that lengthy wet period seems to be drawing to a close, but it really was the wettest such period in about 100 years. Just a few words about lake levels now. This might seem awfully simplistic, but I find it doesn't hurt to just write it down. And if we're considering lake levels on any lake in the province, you need to look at the amount of stream flow coming into the lake, the amount going out, the precipitation on the lake surface, and evaporation from that lake surface. And I did mention that evaporation usually exceeds precipitation. So lakes, to maintain their level, have to depend on some stream flow coming in. And then, of course, lakes also have seepage losses or gains with the groundwater system. And, you can go through scientific processes to examine whether a lake is a so-called gaining lake or losing lake. But in the fairly tight clays in southern Saskatchewan, in general, seepage losses and gains are relatively small, but that doesn't mean that in some cases they're not significant. It just means that on average, they're probably not significant. Another key thing to think about when you're trying to consider what affects lake levels and how they might change is the ratio between the surface area of the lake and the drainage area of the entire watershed that drains that lake. And and of course, the larger of a drainage area, the more potential runoff there is. And you'd expect a lake with a relatively large drainage area and a relatively small surface area to respond quickly to increased or decreased flows. And then the other thing that we find in southern Saskatchewan is that many of our lakes have outlet control structures of some kind. It might be a small dam with stop logs in it. It might be just a weir with no structure or no adjustments, but just a regulated outlet. But especially when I look at recreational lakes, there are very few recreational lakes in the province that aren't regulated to some extent. And so that's another part of an element of understanding lake levels. Oops. I'd like to move to a couple of specific examples now, just to illustrate lake levels and what goes on in Saskatchewan. These are traces of the water levels at Greenwater and Marion Lakes up in Greenwater Provincial Park. And it's a busy diagram. The first thing I can point out is that the green tracers are the water levels at Greenwater Lake, and the blue ones are Marion Lake, which flows into Greenwater Lake. But what I wanted to bring to your attention is that little red sawtooth bit at the top is the regulated levels of those lakes. So that's what humans have done to try to regulate the level of Greenwater Lake. And you can see it's about half a foot or so of change. And so it's really quite a small amount of regulation. And in the wet periods that I mentioned, if you look at the, I don't know if this will show up, but this area here in the 70s when conditions were wet, Greenwater Lake and Marion Lake were up at the top of the regulated level. And then Greenwater Lake bounced up again in some wet period in the mid 80s, which was generally a drought period, and then receded and then came up again in the mid 90s when it was wet again, dropped considerably, and then came up again in about 2005. And those lakes have stayed high since 2005. So what I'm trying to illustrate by this is that the human's effects to control these lake levels is really dominated by natural conditions, so that we do our best to regulate a lake to a certain level, but oftentimes Mother Nature takes over and pushes it up or pushes it down much more than we can control that. And you do see that in many regulated lakes throughout the province. So there's a tendency to think that lake levels can be controlled by turning a few knobs, so to speak, and you just dial in the level you want. But hydrology is more complex than that, and it's very difficult sometimes to maintain a level of a lake that satisfies all potential users of that lake. In a similar note, I wanted to show you traces of some water levels in recent years at so-called closed basins. These are basins in the province that have no outlet, and some of you will be familiar with these lakes. Kenosee Lake, of course, is a significant recreational lake. Redberry Lake is a major conservation area and recreational area. Big Quill Lake we've heard about because of high levels there, and Devil's Lake is in North Dakota, but and Manitou Lake is up towards the Alberta boundary. But again, at these closed basins, you'll see the effects of increased water levels over the last 10 or so years. And again, that's a prevailing effect of climate conditions, because some of those lakes do have drainage in the watershed, and others like Knossi have very little drainage. But again, you see that climate effect on lake levels. I'd be remiss if I didn't say a few words about water quality, and I know that water quality is a huge concern with anybody that has a cabin at a lake. And this is a nice schematic by Helen Broch at the University of Saskatchewan. She's used it in many of her talks in describing nutrient processes, but it basically shows the sources of nutrients coming into a lake from stream flow, from atmospheric deposition. And then, of course, some nutrients leave the lake through the stream at the outlet, but you can have groundwater inflows, groundwater seepage, and that may have some effect on nutrients. And then on a lot of our shallow prairie lakes, this whole question of nutrients settling in the silts on the bottom and then being redistributed by winds and waves and so on is an important fact in understanding nutrient processes in lakes. And as I say, with you know, in looking at algae growth in lakes, we have to consider, you know, the various sources of nutrients, and then start to think about how we control that. And of course, in Saskatchewan and the southern prairies generally, nutrient sources are many and varied, and some of them are natural. We know they're early explorer notes of the green waters of the Capel Lakes, and so there are some natural nutrients in a lot of prairie lakes, but we also have to worry about point sources like sewage facilities and you know, even emptying lagoons periodically. All of those kind of things can become sources of nutrients. But one of the key elements now is we control so-called point sources, whether they're urban or industrial sources. We start to notice the so-called non-point sources, and a lot of those sources tend to be atmospheric deposition or agriculture. And in the case of agriculture, it's a combination of fertilizer, manure, and other residues that end up in the aquatic system. So in terms of reducing algae blooms on lakes, you have to consider not only the sources of the nutrients, but design mitigation measures that specifically address what are the key sources of nutrients. And I just wanted to say a few words about water management in general on Saskatchewan lakes. Generally, it's a provincial responsibility. I mentioned the interjurisdictional nature of water in Saskatchewan, and sometimes water, you know, is crossing a boundary, and that may have an effect on you know, water quality and water quantity concerns, and dealing with those concerns. But the key question oftentimes is the water level and the water quality monitored? And in many cases, the water levels aren't monitored, and if people that are at cabins or you know, recreational lakes, if there's no monitoring going on, I'd almost encourage you to do some of your own monitoring of water levels and different parameters. This friend that I'm visiting tomorrow at Christopher Lake has kept a record of ice formation on the lake for more than 40 years. And it's kind of interesting when citizens take it on themselves to monitor environmental parameters and keep a record of those kinds of things. The other part of water management that's of concern is the presence of a structure on the lake. And as I mentioned, many Saskatchewan lakes have some sort of physical structure. And we need to find out who owns it and whose land is it on, and how is the operating plan determined. And as some of you will be aware, many years ago, PFRA built a lot of small structures on the prairies, but they don't own any of them now. And so in many cases, a structure may be owned by the province itself, a water security agency. It may be owned by a town, or it may be owned by an RM. And knowing who owns the structure and who's really responsible for maintaining it and managing it is key to coming to grips with the recreational lake problem. The other thing that you find out is that knowing whose land it's on is also important, because I don't think I have to tell anyone here that in many cases, structures were built at the outlet of lakes on indigenous lands, and it was very rare when governments actually got full approval to do that. So, you know, we need to understand who the landowner is, and sometimes the landowner isn't the owner of the person who built the structure, and the land ownership may even be questionable in one sense or another. The other part of this is then knowing that is, how is the operating plan for that structure determined? And for larger structures, the Water Security Agency has a key role to play, and they're often the ones that know what's what on in operating a structure. But certainly knowing who owns that structure, whose land it's on, and how is the operating plan determined is very, very key. I should mention, of course, too, that even when a structure is owned by someone else, you know, an urban center or perhaps Ducks Unlimited, the operating plan is usually approved by the province, even if it's not determined by the province. So there's, you know, we need to understand those questions about ownership of the structure of the land and responsibilities for the operating plan. And then just in terms of water quality, again, the Water Security Agency is the key player on water quality matters, but understanding the effects of point and non-point sources is a key element in lake water management and coming to grips with some of those lake management issues. And I think that's it for me. If there are any, I guess we'll take questions and discussion later, but I'll turn it back over and
now, I assume, Chuck, if you're back there, that we haven't heard anything more from Alice.
No, we have not.
Okay,
So
just to explain, Alice contacted Chuck earlier today about an emergency that had come up and explained that she might not make it. And if that is the case, our plan is to post her presentation on the park's website and advertise that that is happening. And it seems that that is the case. So now we're going to move right to was normally our third presenter, who is now our second and final presenter, and that's Jeff Olson. Now, Jeff is a retired conservation officer, and as I understand, he has extensive knowledge about farmland drainage and wetland, and has had a lot of experience as a wetland specialist in the Parklands ecoregion. And in the last 14 years of his career as a watershed planner with the Water Security Agency, he is the founder of the Saskatchewan Environmental Alliance, a group of concerned folks who are working on innovative solutions to contemporary environmental problems. So he is an action man, and we are anxious for him to talk to us about his actions. It's yours, Jeff.
Okay.
Just they get rid of me. There.
Thanks, Lynn. Thanks, Lynn. And I'd like to thank Parks for inviting me today and the Citizens Environmental Alliance to this webinar discussion forum. I should be sharing my screen there, and everybody should see it. Today, I want to talk about the farmland drainage impacts to recreational communities in the province, and so we talk about directly agricultural drainage and why it's important and the size, and it's actually there is about 1.6 million to 2.4 million acres of land that have unapproved drainage works, and we'll get into some of what Bob has talked about in the effective in the gross drainage areas and how that applies. Of that, there's 100,000 to 150,000 with unapproved drainage in the province, essentially illegal. And even then, we have some licensed drainage, and that's about 1,800 miles of organized drainage ditches. As I said, 95 to 99% of the drainage is unapproved and illegal. So these three pictures just show a case of drainage works in the province. The top right was the local RM who went through Wildlife Habitat Protection Act land without permits, resulted in a court case and a conviction in that one case. The bottom one is Van Patten's Creek running into fishing lakes near Croaky, and that occurred just a couple years ago. I'm not sure what the follow-up is, but Van Patten's is a major fish spawning area for the fishing lakes itself. And as far as I know, there's been no action by Water Security Agency to either mitigate or have the landowner brought to court for that. The top left one is a major structure, again, without any type of licensing. How is it right now? WSA funds drainage purely for economic development. The fact is that although they're entrusted with protecting watersheds and that sort of thing, economic development comes first. Essentially, farmers can drain as much as they want. The Water Security Agency is very ineffective in enforcement or getting people to comply to the legislation, and has been that way for years, and that needs to change. There is no assessment of cumulative impacts. Even when they license drainage works, they don't consider a whole watershed and what it might do. I'll discuss later on how that can affect both flooding and nutrient loads to lakes downstream. The provincial auditor warned in 2018 that Water Security Agency has no policy and can't or doesn't have any way to prevent the impacts, and is not presently assessing the risks of illegal drainage. And Saskatchewan is still the only province without a wetland conservation policy, and I'm sure most of you have heard the concern surrounding that. So why be concerned about farmland drainage? And in a greater scope, not only as a resort community, but also as just the communities in the cities and other farmers. Is, you know, we need water to live. It is our most precious resource, natural resource. We depend on it for drinking and recreation. Fish and wildlife depend on it for clean water and its use. The farmland drainage affects the quality of water in the lakes, and groundwater included, and drainage affects how sediment, nutrients, and other materials get transported downstream. And we just heard at a webinar that we hosted that the drainage of wetlands causes methyl mercury to move downstream and potentially accumulate in the lakes downstream. As Bob pointed out, the gross drainage area being the whole watershed area. The gross drainage area is the effective drainage area, that 1 in 2 years essentially when it normally contributes water to the stream flows, then the non-contributing, which doesn't normally contribute runoff. And this is just an easy diagram to show, you know, effective drainage area, the gross drainage area, and that what it would stand naturally. And then when you're now adding, excuse me, farmland drainage to the area, you're increasing the effective drainage boundary area, and most of the time significantly. As Bob mentioned, that the red area is the non-contributing area, so much of Saskatchewan prairie pothole area was non-contributing in a natural state. This is Blackbird Creek drainage near the east central area of Saskatchewan, a existing but proposed to be licensed drainage works, about 19,000 acres. Blackbird has a gross drainage area of about 20,000 acres. Historic effective drainage area of 5,000 acres. And once the whole drainage project is licensed and okayed, the fact will be that it'll be 17,000 acres or 91% of the gross drainage area. So it's a significant amount, it's almost more than tripling the amount of new effective drainage area. Therefore, more nutrients coming off of agricultural land, contributing downstream and ending up in the lake. In this particular case, this lake is Lake of the Prairies, and just into Manitoba. This one's a little closer to home, and this is wetland loss in St. Gregor area in Saskatchewan. It's upstream of Last Mountain Lake, would be in the Lanigan Creek area from 1974 to 2002. The total amount of wetland area drained has increased by 90%, where the amount of water that used to come downstream and how much is the effects to Last Mountain Lake as far as flooding, I'm not certain. I don't know if Water Security Agency has ever considered or did any studies to that effect, but with 90% of the area just in the St. Gregor Conservation Development Authority being drained, it would have significant contribution. There is other conservation and development areas upstream in that area as well. So there's you see along the watershed in the far north, and it flows down south into Last Mountain Lake and affects those resort communities, ultimately getting into the Qu'Appelle system as well. So what are the impacts to farmland drainage to resort communities? As the easy one is seen most of the time is flooding, flooding of cabins and campground areas and recreational areas, nutrient loading and loss of biodiversity, loss of habitat, both fishery and wildlife habitat. When you get this type of flooding, the fish habitat changes significantly and can affect the spawning of the fish. As well, we have climate change impacts from the loss of those wetlands upstream. Some resort communities, in this case, Fishing Lake, Waldsee, Dead Moose, and Houghton Lakes, had major flooding. It was found that the Water Security Agency's own report that a significant amount of wetlands were drained, and the contributing area doubled the natural area that once existed. So there was significant increases, both in fishing lakes, in Waldsee, Houghton, and Deadmau5 Lake. So that just goes to show you, and the photo there of the extent of damage that can occur, especially in those basins that are terminal or next to terminal. In the case of the Water Security Agency's response to fishing lakes, they constructed a berm and constructed a channel to allow the water to leave the lake. I live not far from there, and I was involved early on in some of the discussions when I was with Saskatchewan Environment, and how effective that outlet remains to be seen, as we don't see Manitoba allowing a lot of releases from there, or significant releases, and that the area is so flat that it really can't flow that well out. If anybody's listening from fishing lakes, I'd be interested in hearing your views on that. As of this, not one illegal drainage ditch was closed. So even though you might have protected the flooding of the cabins and the infrastructure there, that will not have taken away from the amount of nutrients and methyl mercury that's potentially getting, or is getting into your lake, until what levels we're not certain. Illegal drainage continues, and again, it's not that that Water Security Agency isn't stopping any of it. It continues. Land values continue to go up, and some farmers insist on developing that land through drainage. And fishing lakes is now experiencing major algae blooms. And of course, there's a big cost to taxpayers throughout the fishing lakes basin as a result of that flooding. In the case of Waldsee and Houghton, the construction of berms for the cabins, or they wanted to construct a drainage channel, but weren't allowed as a result of the impacts to Lake Lenore. They eventually destroyed many homes, as well as moved some. Again, no illegal drainage ditches were closed, and still the illegal drainage continues. The cost to taxpayers was significant, in the millions of dollars. 2021 Auditor's Report is a follow-up to the 2018 Auditor's Report regarding Water Security Agency's review of the Water Security Agency policies. It was found in the follow-up report in 2021 that I think only one recommendation was fully implemented, and the remainder were partially and not very well. But the auditor said they still need to develop the policies around wetland retention and water quality. That wasn't done. Major shortfall. They need to take enforcement action when the landowners do not resolve complaints. Water Security Agency is an enforcement agency enforcing legislation, and yet they don't act as they are. They really don't have enforcement agents of any kind, not like conservation officers who would be willing to do it, but are prevented from doing so. They do not document large-scale water impacts of proposed drainage projects. Much of it is of the bare minimums and the hydrology of it, and how much water is going to be going downstream, and not water quality questions. And they're still not searching for unapproved drainage in high-risk regions of the province, such as contributing to lakes that are terminal basins, or lakes that already have water quality issues, such as the Qu'Appelle chain or Last Mountain Lake. So the bottom line is that they need to do a lot more than what they are doing. One of the things is, and you've heard, is that Saskatchewan needs a wetland conservation policy that will go hand in hand with a farmland drainage policy to look and assess what the impacts of that drainage would be to downstream receiving water bodies on fish habitat or wildlife habitat in the area, as well as on water quality. So right now, WSA is promoting ag drainage without adequate or any mitigation in some cases, and they don't enforce the law and close illegal drainage unless they receive a written complaint. And that's problematic because essentially you're pitting neighbor against neighbor to report somebody and then testify in court against them. So I just have my contact information here, and if anybody would like to see any of the presentations that were done regarding the methylmercury or nutrients in water, that sort of thing, they can all be found on our YouTube channel. Thank you very much.
Thanks, Jeff, and thanks, Bob, as well. So we'll move now into the question period. So if you have a question for either Bob or Jeff, simply raise your hand or type a question into the question box. Go ahead, Brian, you have a question?
I do. Can you hear me?
Yes.
Okay, so first I want to thank both you guys for really getting to the heart of the matter. And I have a question for Bob and I have a question for Jeff. So Bob, one of the considerations when you're talking about climate change, and we're talking about, years, your sketches where there's dry years and wet years, all the indicators are suggesting that there's many dry years are around the corner. And I guess my concern is, or my question is, what is the strategy to manage that water in the change into that change of environment, and whose responsibility is? And I think I know the answer. I'm just curious to hear what you think. And I want to know, what can we expect? And I'm talking specifically at Humboldt Lake here. We're reading all that narrative. We've been studying this programs for about a year and a half now, and we're behaviorally, we're not seeing anything that's consistent with the narrative on the Walk Water website or the Langan Creek Delwood Brook or the WSA websites. And we're sort of, did we miss a memo somewhere, or what's your thoughts?
Well, first off, on the prairies, we're dealing with a highly variable resource, even without the effects of drainage and climate change. And I used to go around giving climate change talks and saying that it's going to get warmer and it could be either wetter or drier, which isn't really a very helpful observation. But there is an emerging consensus that there will be more water in the system in the future. But there's also a very strong consensus that that's going to be the result of extreme events. We won't have the 3-day soaking rain. We're going to get the extreme thunderstorms and that sort of thing. And on the dry side, there's a considerable probability of long droughts. When we had the 2000-2001 drought in Western Canada, it was the biggest, if you like, environmental risk we've experienced in many, many decades. And but it only lasted a couple or 3 years. But and people can sometimes cope because they're used to this variable resource we have, they can kind of cope for a couple or 3 years, but you get much beyond 3 years and you really start to suffer. So I would, you know, if I was going to make a forecast myself, I would say that there might be more water in the system. We don't know when we'll get it, and it might be so much water that we have, you know, floods as well as still having droughts. So that's the challenge. The other side of that is that I'm an engineer, so I can say this, but when engineers design things, they tend to base it on past practice and standards and codes and all of that. And for any engineered structure to be designed to withstand climate change, people have to make assumptions about what that future climate's going to look like. And that's very challenging if you try to turn it into a code or a standard of practice. And so I know in my day, when we used to design a dike, we'd say, well, let's just build it a meter higher just in case, you know, that kind of thing. And there's a challenge there in doing those designs. The other thing that's, I think from a flooding and drought perspective, I'm a firm believer in looking at flooding and drought issues before you have the event, and you know, trying to make decisions on extreme events during the extreme event is just fraught with problems. And we need to make sure that we've looked at some of these and applied the best science. And I know I used to manage scientists, and I said, well, you know, in a court of law, you know, it's you know, sometimes beyond a reasonable doubt is a test, but in the other cases, it's a balance of probabilities. And so, you know, if your best judgment as a scientist is that this is the outcome that you'd expect, you need to share that with policymakers. And policymakers have to understand that that's a best judgment call. It's not a prediction. And climate scientists like to talk about scenarios and outlooks and all those kind of words, but the fact is we don't know exactly what we're in for, but it's probably going to be somewhat wetter on average, definitely warmer, and more likelihood of extreme events. So in your specific challenge, I think you need to consider that you could have higher lake levels, lower lake levels, and you know, there's a need to at least be prepared for those kind of outcomes. In terms of who's responsible, I think in many cases, the science that drives climate change is international or federal science, but the managers are the provincial agencies, and there's a real challenge in translating current science into provincial policy.
Okay, can I have, thank you very much, Bob. Can I ask Jeff a question, please?
Go ahead.
Jeff, I was very interested in your perspective on what you're seeing. And that's really consistent in many cases what our condition is here. So I want to talk just a little bit about Walsey Lake. My mom and dad looked after that lake for 15 years. I learned to swim at that lake. I watched that lake evaporate. There was a time when that was all kinds of activity out there, and it was a real alive. It was a provincial park, gone. At Humboldt Lake, I'm again a resident of Humboldt for many years, and we still have a cabin out there, and I'm talking to you from that lake as we speak here, for example. So when I take a look at, and I'm sort of talking to you a little bit sideways, Bob, but not disrespectfully, but our lake has been managed and managed by the WSA forever. It's been monitored by the University of Saskatchewan, U of R, for the last 40 years. And when we take a look at that data, we find kind of interesting things. The first thing is the science tells us exactly what is the properties of a healthy lake. That's great. The research that we have from the U of R for the last 40 years tells us exactly what the profile of our lake is. Oh, great. The science also tells us what we can expect typically when we take a look at 100 water bodies around the world, that we can see about 39 or 40% of the nutrient load coming in is coming in urbanly, and about the same amount is coming in farmland. Okay, all right, fine. But But the math, when we take all that public domain information, the math tells us that Humboldt Lake is about 6 to 10 times higher nutrient levels than what's considered a healthy lake. The math also tells us that the city of Humboldt's treated effluent coming to the lake all by itself is more than Humboldt Lake can manage. So when I listen to Lynn talk about, the responsibilities that we have as a province to manage these water bodies, I'm just not seeing it at Humboldt Lake. The lake continues to deteriorate. Not only did we have a fish kill that the WSA concluded was total last year, but we also have not enough oxygen levels to reseed that lake. So, when I read the WSA and Walkwater's website, I see all this compassionate narrative, but I don't see anything happen behaviorally. What are your suggestions, Jeff? It sounds to me like there's a little bit of frustration in your presentation as well. What are your suggestions? What can we do to get the decision makers that are entrusted with our water bodies to get excited about doing something behaviorally? What can we do?
Yeah, that's an age-old question about how you can get politicians to really do anything, almost accepting when they go to get reelected in some ways. I mean, a lot of times you need to take them out there and show them, and I expect you probably have showed them, the difficulties you're having and that sort of thing, and then get some commitments from them and have the civil servants in the Water Security Agency agreeing to that. If the nutrient loading that's coming from the city of Humboldt is to that extent, then the city of Regina had to deal with that. I think that the city of Humboldt should also deal with that. When it comes to the farmers who are illegally draining or are not using the best management practices to limit the amount of nutrient loading to the lake, then that needs to be done as well. I'm not overly familiar with Humboldt, so I don't know how much drainage of additional effective drainage areas there is above natural, but I take it, do you have a lake stewardship group of some sort or some sort of organization at Humboldt Lake that, of course, many voices.
So in the first place, I don't mean to interrupt, but in the first place, the South Humboldt Water Users exists in response to the city of Humboldt's requirement to have a single body out here. So we speak for the entire community. The second thing is we have a group that's a subset of that group that is the concerned individuals for the rehabilitation of Humboldt Lake, and we've been rattling around for quite a while. We've been moving forward with science, math, and research, and really diligently but respectfully petitioning the WSA and Walkwater and Langdon Creek, Delwood Brook, and the city of Humboldt. We've been relatively well received, but there's been no behavioral changes out here. So we continue to persist, and that's why, you guys are really interesting. When you talk, Bob, about that you're an engineer, well, I'm 45 years in the construction industry. I'm used to dealing with architects and engineers, and I take no issue with you guys. I think collaboratively we're a good team, but I think ultimately, and we're really good when we get to make those decisions. It's just we get a little bit behind the 8 ball when somebody else is making those decisions. And to me and you, to the three of us, I think the way forward is relatively clear. But there's the decision makers seem to have a myopic view, and we've been. Would it be too much to start moving up to the our provincial counterparts who are these elected representatives who have entrusted this authority and responsibility to these watershed groups, stuff, and to actually sort of petition them, saying, I think there's something I think changes are required here. And one of the things that we've always done when we've gone to the city of Humboldt, we said, listen, This is not about our lake community. This is about the benefit of this lake community to this area, to this large area. This is a recreation park. People grew up swimming at this lake. Well, you couldn't swim in it now. I mean, you can't fish in it now. And with the city of Humboldt in a 10-day delivery of treated effluent, you don't even want to be near it. So what we're really looking for is we're looking for the decision makers to recognize that there's an obligation to take some action here. And man, I'll tell you, like we write and we present as much as we can, but if if you guys have some suggestions, I'd love to hear them. And I'm not being, I hope I'm not coming across as frustrated. I'm just coming across maybe as a little intense, but.
I think over time, one of the things is when I was a watershed planner within the Water Security Agency, and it was recognized that the communities that still had wastewater effluent, sanitary sewer, lagoon effluent being released, over time, that has to be grandfathered and gone away. They need to find a alternate way of disposing of that effluent, whether it's effluent irrigation or water reuse or something, but because right now it's just contributing too much nutrients. I mean, that's one of the biggest problems that we have or had in Lake Winnipeg was effluent releases, and they all accumulate and get downstream and cause many problems, and they're almost killing Lake Winnipeg, and I would suggest they may be killing Humboldt Lake the way things are going. So the bad news is people don't do anything until there's a crisis. When, like you said, people can't swim there, people can't fish there, nothing, and then they go, look at what we've lost, and the cost to rehabilitate that will be multiples of what it would have cost to address the problem now or originally.
Just maybe a slight addition, and it's a case that I'm fully aware of because of my work in Manitoba. But years ago, when Winnipeg was almost wiped out by a flood in 1997, there was a lot of studies and conclusions were reached about enhancing Winnipeg flood protection. And the city of Winnipeg and the province of Manitoba, the feds were handing out money. The city of Winnipeg got the province to say, this is our #1 economic development proposal for Manitoba. We want flood protection for Winnipeg. And I think oftentimes, I'm guessing, but I have no idea of knowing, but if you go to a small community and you say, well, can you get even the city council agree that enhancing sewage treatment is their #1 priority? And if somebody offers a new arena, would they take the arena and forget about the sewage treatment? But I think at some level you have to start at the town level and say, when there's provincial money coming our way, we want some of that to go to reducing the effluent flow to Humboldt Lake. And but it's very, very rare. And I mentioned the Winnipeg case only because it's one of the few I've heard of where a province actually said our #1 priority is to protect our people from future environmental risks. And it doesn't happen often in Canada.
Thanks for the discussion there, Brian. I see you've got your hand up again, but for the sake of time, we're going to move on to some other questions and we'll circle back to you if time permits. Jacqueline, you had your hand up. Did you have a question? Just unmute yourself if you do. There you go.
Oh, there it is. Oh, sorry. Hi, Jeff. I haven't seen you in a while, but great presentation. Same thing for you, Bob. Wonderful presentations. I absolutely enjoyed those. My question was for Jeff. Since this whole thing about like policies, not enough enforcement is really disheartening since there's not enough. Absolutely agree with that. It's part of my thesis, actually. In your knowledge, like, have you heard of any policies or practices where agencies have been trying to incorporate communities to be more involved in like nutrient management within their watersheds, like citizen science or anything like that? Like, have they tried initiating anything like that, or is it just not happening?
Well, when it comes to Saskatchewan, like the Water Security Agency went away from lake stewardship groups and the citizen science. I know there was executive level arguments about citizen science not being very good and that it lacked efficacy and that sort of thing. It really bothered me at the time because I think citizens can do good science, and many are wanting to do that, and it could or should be used by the agency such as Water Security Agency, and isn't right now, and there's no support for them, which is, I think, ridiculous. It's one of those things that things go on in Moose Jaw and they decide what happens. And for instance, even with it comes with Humboldt Lake, I don't know how much communication they've had and direct input into what goes on in there. I know when it comes to Lake Diefenbaker, there's still no operating plan. The Water Security Agency operates it as they see fit in conjunction with SaskPower, even though there is to be an advisory group and there is major concerns from right from Cabri to downstream in Outlook regarding it. So the idea of having more public input into water management decisions or water quality or even the research is not well recepted at Water Security Agency right now. That's the long and short of it.
So do you think doing research to test the effectiveness of some different types of methods for citizen science to see if we can prove that, yes, citizens can definitely get decent results with these methods? Do you think policy makers or decision makers would kind of change their tune?
Well, you know, I'd always like to think common sense and some good thinking by anyone at the executive level would say, you know, yeah, that makes sense and that's good. And I think it could easily be done. You know, I was involved when I first came over from Saskatchewan Environment to the Saskatchewan Watershed Authority initially in 2002, and the fact was we said then we should have more citizen science, but no, I think a program initiated, especially from the outside and brought to the executive level there, would at least be listened to, and if it makes science sense, I mean, I cannot see them. Well, I could see them not doing it, but it would make no sense them not doing it. So we have citizen science all over the place. Like, why is it boxed so much here? I don't know. Walkwater has a little bit, I understand, but I know that an individual from a lake near Yorkton has been trying to get some citizen science and water quality testing and that sort of thing on his small lake that's next to a community, and he cannot get any reception from Water Security Agency on it, or actually any other agency right now.
Wonderful, thank you.
There are some
yes.
examples on the flow into Lake Winnipeg of citizen science doing nutrient monitoring on some of those tributaries into Lake Winnipeg, and the people are dedicated and they do good work, and basically it's a gift to governments.
Thank you, guys. I was really hoping to hear that. It's kind of something I'm doing in my thesis. That's really, it's really encouraging to hear.
Okay, our next question is from Gary Dixon. Gary, did you have a question?
Yeah, and both gentlemen can answer, but maybe directed more to Jeff. If Water Council of Canada is formed and particularly headquartered in Saskatchewan, do you think they would have enough influence in Saskatchewan for the government, I guess under WSA, to do some of these conservation policy, wetland conservation policy formation, and, you know, sort of force the provincial government's hand on setting some of the drainage policies and so forth? I'll leave the answers to you. Thank you.
Well, from my perspective, I definitely think it would. I mean, to be the province hosting the Canadian Water Council, I would suggest that they would probably highly consider ensuring that they adopted the policies that all the other provinces would, and that sort of thing. And I think one of the nice things would be the federal government bringing funding to the province to do not only this or other good work in other provinces that is being seen. So yeah, that can do nothing but benefit not only Saskatchewan and the good policies that we need for its citizens.
Good. We have a question that's been typed in. So the government recently announced a major irrigation project, which is proposed to feed off the South Saskatchewan River. Has anyone looked at the potential impact of that project on the downstream lakes and wetlands?
Just I can take an initial run because one of the hats I wear is with the Saskatchewan Environmental Society, and there is a piece on their site that discusses the project and some of the environmental consequences of that project. So that would be a starting point anyway. Basically, the society is calling for a comprehensive and environmental assessment of the project.
Yeah, the Citizens Alliance, Environmental Alliance is in the same situation. This is a mega project. The amount of impacts to Lake Diefenbaker and in other areas, even downstream into the Buffalo Pound, Qu'Appelle chain is going to be there. The questions are more than questions. It's a fact that the impacts are going to be there, and we've called on the federal government to undertake a full environmental assessment of the projects involved. And there's a lot of, and this is where you get into the environmental assessment, is there's a lot of unique areas to be hit on in the environmental assessment, not only the hydrology, but the impacts to wetlands, the impacts to downstream. People don't realize that irrigation itself has major water quality impacts downstream because of the water returns from the irrigation projects. So there's no doubt, and we're calling on, as well as a multiple of other environmental and non-environmental organizations for a good look at this before it proceeds ahead. Even on the economic development side, the cost is questionable, and I understand the Canadian Taxpayers Federation is concerned. So we're looking at it. It's not going to happen overnight, but we've already started on some of the aspects of that.
Good. We have another question here. Besides nutrient levels, has there been any chemical studies? They've expressed concern that as wetlands get drained and sprayed, that flows downstreams, and they've witnessed creeks without aquatic life, and are concerned about those downstream impacts and on amphibians.
Yes, the interesting part is that I don't think, and I know the watershed groups that came about as a result of the watershed plans have always been calling on more water quality testing. The water quality testing is unique, as in you just don't take a sample and say what's in it. You don't do that. You have to target exactly what you want to be testing for, and like whether it's lead or whether it's 2,4-D or whatever it is. So there's a cost factor and that sort of thing. Methyl mercury, we know now, is being a major contribution. There's problems with glyphosate now being entered. At one time it said it wasn't water soluble, it was destroyed in the soil and there was no problem. If you have an area that has a major die-off of whether it's plants or animals, you should be reporting of that to your conservation officer, whomever, who can look into what may be causing that, if there was a major chemical spill upstream, or whether it was a improper disposal of some sort of insecticides or that sort of thing. We really are, technology is a great thing, but we're really ramping up how bad the number of things we can do to ourselves in the environment as well. So, Bob, did you have a?
Yeah, there's another element there as well. When you start thinking about downstream effects of drainage, when you're measuring water quality, you measure really two things. One is the concentration of a substance in the water, but important consideration is the load. And in the old days of water quality monitoring, generally speaking, technicians would go out the first Monday of the month and take a sample somewhere. And then with time, we learned that what you have to do is follow the stream flow record. And so when there's a high flow, you're out getting samples. When there's a low flow, you're getting samples. And and that allows you to calculate the load of material going downstream. And so, during a high flow, the concentration may be relatively small, but the volume of water is large. So it's transporting a considerable load of material. And we need to understand both of those things. And so it's challenging, and and for many things like metals and pesticides and sort of more exotic materials, it's expensive to collect all those samples.
Okay, we have a question from Eddie Thompson. Eddie, did you have a question? Just unmute yourself there, Eddie, if you have a question. Eddie, did you have a question? Just unmute yourself. Okay, Brian, did you want to have another question here?
I did. I wanted to just give you guys a little bit of the framework that's happening here so that you can understand maybe the context. The city of Humboldt has approved for a $34 million new wastewater treatment plant last year, 2009 or 2020. They also have engaged a consultant team already. That design is happening. When we presented to the city of Humboldt in December, we had three options. One of them was to divert around the lake. The second one was to irrigate, and the third was to go north into Houghton. And because that lake is down about 12 feet now this year, so we're familiar with the moratorium, and that was actually, we understand why that wasn't pursued. The city of Humboldt has actually expended $40,000 examining and investigating the option of going around the lake. We gave them a pretty detailed proposal. They haven't made a decision on that yet, and they've currently asked us for some more information as it relates to the participation of the farming communities that would be interested in irrigation in principle. So we're currently putting that together. So I wanted to make a point, and the WSA is also, we have presented our math to them on the basis of research and science, and they have advised that it will provide us with a written response. So there's no commitment from anybody, but what there is there's a lively discussion happening. So I just wanted to sort of give you a little bit of context for my comments there and stuff like that. And I go right back to where I started. Like if we've missed something and you have some suggestion of what might have worked or what has worked, because we'd certainly be prepared to listen to that.
Well, that's gratifying. That I had the impression that nothing was happening, so that's that's gratifying and comforting. I guess the thing that I think they'll find is once they've dealt with the Humboldt treatment plant, you're going to find that all these other sources of nutrients just jump out at you. And so, then you'll be having to look at agricultural runoff and all those other issues as well. So I wouldn't be shocked if Humboldt did what they say they're going to do, and but it'll still be more work is needed. But I think you have to be ready for that outcome as well.
Yeah, the biggest thing that you're working together and talking, I mean, that is great. I mean, that is the way forward. I mean, it would be very bad if they were just sticking to their guns and gonna do whatever they darn well please. So no, that's refreshing.